Today we will speak about checkpoint VRRP cluster. I will not discuss VRRP as the first hop redundancy protocol because it is more part of a network knowledge rather than a checkpoint knowledge, but we will create a VRRP cluster and we will see how VRRP works with the checkpoints. This weekend, the gateways and smart management server had their licenses expired because of this 2 weeks limitation since the first time configuration wizard was run. So I rebuilt all the 3 VMs and installed Gaia on all the 3 VMs with exactly the same steps as in the first video of this channel. And I will use this chance to rebuild the gateways not as a cluster Excel cluster, but as a VRRP cluster. To do this, I will need to run the first time configuration wizard on both firewalls with exactly the same steps. The only difference will be the type of the cluster that I will select at the certain point in the first time configuration wizard. Click Next, Next. That's our management IP. This is our external IP. 1.2.5.2.5.2.5.2.5.5.0. The name is Lab Gateway 1. No NTP for time. Security gateway. And we uncheck security management. And this is a part of the cluster, and this will be VRRP cluster. And here we have the warning. So first, we need to invoke cpconfig and enable clustering, and second, we will need to configure VRRP using VRP UI or command line shell. So that's exactly what we will do before we will create a cluster in SmartConsole. We should select an activation key. And immediately let's go to the second firewall. Again, uncheck security management, check the cluster, and it is a VRRP cluster. The activation key. And here we have the installation ongoing. Sorry, first time configuration wizard ongoing. First time configuration wizard is now complete, and we can log into the firewalls and perform the basic configuration that we did in the previous videos. Let's just repeat the steps. First, we will set expert password. Then we will set administrative shell. Then we need to check what we have with the interfaces. We have Ethernet 0, Ethernet 1, we don't have Ethernet 2. Let's come back to Clish and set interface IP address. Now we have the interface Ethernet 2 enabled, and with that IP address it will be our sync interface. And we have management, we have external, we have sync, so we can save configuration, and we can do the same on the firewall number 2. Set expert password, set admin shell, set Ethernet 2 IP address, okay. We have again management, external, and the sync interface configured. And the next thing to do, we need to check if we have cpconfig enabled and cpconfig with a cluster membership, and we will log in again. Now we are right in the expert mode. We do cpconfig, and here we don't have cluster membership enabled, so what we do, we select 6, and we want to enable cluster membership, and this will be applied after the reboot. So just in case, I go to Clish and save config, and then I reboot. I will not wait until this firewall will come back, so I just go ahead and do the same steps on the gateway number 2. Again, we need to enable cluster membership. And the gateway is going for reboot. So let's wait for these 2 firewalls to come back after reboot. Firewalls are back from reboot, and we can configure VRRP on both the firewalls. Let's start from the gateway number 1. We need to switch back to Clish, and the first step is to create a virtual router ID, and this can be done with the command add mcvr where ID, let's say 100, and this will be the primary firewall. It must have the high priority for the virtual router ID. Let's say we will set the priority of 150. Okay, and priority delta, so in case if any interface goes down, we need to specify how much of priority it will lose. We will say, let's say it will lose 10. And you can also specify the hello interval. Let's say hello interval will be every second, and we will not add any authentication. Now we have the router ID, and we can check it, show mcvr VRIDs. We have just one router. We have priority, hello interval, delta priority, and we don't have any authentication. Now we need to add virtual IP addresses to this virtual router. For this we do add cvr VRID 100 backup address. This will be the virtual IP for external interface 172.16.1.1. What else can we add? We can add vmac mode. vmac mode will be default, nothing else, and then we press enter. We also want to add another backup address for the management interface 192.168.168.43.5. That's the same virtual IP that we had on cluster itself for the management interface. And okay, what's the problem? Yeah, that's a typo in the IP address. Let's check. We have show mcvr VRIDs. Now shows two virtual IP addresses, and we have the router ID 100. We have priority, hello interval, delta priority. So everything we need we have. We can exit. Actually, it's better to save config first and then exit. Let's log in to the gateway number 2. Go to Clish, add mcvr VRID 100. Should be the same virtual router ID as our primary firewall. Priority of 145. This way we will ensure that if any interface fails on the primary, the priority of the primary will be decreased by 10 points, and this will make it lower than 145. And this will cause a failover from primary firewall to secondary firewall. Priority delta will be 10 as well, and we don't have authentication type, but we will set hello interval for 1 second, and this is the command to create the virtual router. Now we will add backup addresses the same way as we did on the primary firewall. Where ID 100, backup address 172.16.1.1, and vmac-mode default. And the other IP address for management interface 43.5. And now we can save config. Show mcvr VRIDs, and that's our two addresses here and here. Let's check what is our VRRP status now. If we go show VRRP on the gateway number 2, we see that both interfaces are in backup state. And if we will go to the gateway number 1, we see the same. Both firewalls are now in the backup state. So what's really going on? We have another command, show VRRP stats, and show VRRP stats show us that actually, despite of the fact that we have two interfaces in VRRP, none of these interfaces send any VRRP related packets at all. So we have zeros all the way around, which means that for now VRRP is configured, but it doesn't really work. To fix this, we need to log into SmartConsole and create actually a cluster object. In the cluster object, we will need to specify that this is a VRRP cluster, and then we will need to install policy. Now we can start SmartConsole. Here we already have the smart management IP address from the previous lab, and we just need to enter the password and log in. We see that here we have only one object, that's the smart management itself. We will do new, and we will have a cluster. We will go with the wizard mode. Cluster name will be lab cluster. IPv4 address of the cluster, that's not the management IP address of the cluster, that's the main IP address of the cluster. Usually this is the virtual IP of an external interface. 7.2.16.1.1. Don't have IPv4 address. This is Gaia VRRP cluster with high availability. Load sharing is grayed out, not possible for Gaia VRRP. Let's click next. Now we can add new cluster members. WAP gateway number 1. Here we set up the management IP address. This address will be used to set up the security internal communication. 192.168.43.2. Now IPv4 address. Activation key should be the same activation key we used during the first time configuration wizard. And then we tap initialize. And trust is established. Okay. Here we have the cluster information, and we can add a new cluster member. WAP gateway number 2, 192.168.43.3. We used 43.2 previously, now it's 43.3. Then the activation key is the same as we used in the wizard, and initialize. Trust is established. Okay. Two cluster members. We can click next. This is the sync interface, primary sync. Next. This is the cluster interface, which means that the cluster IP is 172.16.1.1 and mask is 255.255.255.0. You can click next. This is also a cluster interface for us because we want as many cluster interfaces as possible. Usually we don't specify a cluster IP for management interface, but for the web we will. .5, the same address as the previous web. And we can finish. Before pushing this change, let's do some changes in the policy. We need to create a rule above just for management. It will be some name like for the admin laptop. Here we need to add the objects for the admin laptop, the new host object. One 192.168.43.1. Let's click OK. Admin laptop will be able to go anywhere by any port with accept, and we will lock everything What we also want to do, I want to allow all the communication between two cluster members that we have. Usually it is an implied rule, but just to be 100% sure that VRP will work, I will add another rule. Here we will add an object, both cluster members to both cluster members, so they will be able to talk to each other by any service and accept and work. So this rule is needed just for the web, so none of the VRP packets will be drawn between each cluster member. Again, usually this is part of the implied rules, but this may make our life a little bit easier for the web. Now we can publish. Okay, publish is complete. Now we can install policy. Policy installation is successful. We can close. And let's check what's going on with the VRP status of our firewalls. Let's open SSH session to gateway number 1 and another one to gateway number 2 and put it side by side like this. Now we can go Clish and do show VRP. The gateway number 1 is in master state and gateway number 2 is also in the master state. Again, something doesn't work. Before the policy install, we had both firewalls in backup state because both of the firewalls were not sending any VRP advertisements. Right now, we have both firewalls in the master state. Master state on both firewalls usually is the consequences of both the firewalls does not receiving VRP advertisements, but sending VRP advertisements. We can check it with the show VRP stats on this firewall and the same comment on the other one. We see that both interfaces sending VRP packets, VRP hellos, and none of the interfaces actually receiving VRP hellos. And because of this, both firewalls thinking that they are the only master in the VRP cluster. What can be the reason? Specifically, when we already configure the rule that both the firewalls can be source or destination for absolutely any service with a accept action. Still, for some reason, advertisements cannot be seen. Let's do a little bit of a troubleshooting. We do a ctl zdebug plus drop and press enter. So what we see here that actually for the VRP address, the advertisement is dropped, and rule-based drop on where network, rule number 3, means that all the VRP advertisements are dropped by cleanup policy. To make output better, we can do grep and then put the VRP address here, and let's do the same on the other firewall like this. And here we see that exactly the same thing is happening on both the firewall cluster members. The VRP packets are dropped by rule number 3. But we have the rule, right? So what can be wrong? We can go to the gateway and servers. We can go to the cluster object, network management. Here we have the topology. First thing to try to do, we can get interfaces. We can get interfaces without topology. What we see that interface names changed. That's a good sign. We still can press OK. Yes. We can publish. What else can we do? We can double check, okay, what exactly is the gateway number 1 and what exactly is gateway number 2. So that's the IPv4 address for gateway number 1, and that's the IPv4 address for gateway number 2. Maybe what we want to do, we want to replace these objects with a cluster object instead. And here we will put any, but here we will add a VRRP. And now we will publish. And install policy. So installation is successful. Let's now double check if it helped to resolve the problem with VRRP. Again, gateway number 1 is master, and gateway number 2 is now backup. VRRP starts seeing that we have one advertisement received and a lot of advertisements sent. Here we see the other way around. We see less advertisements sent and more advertisements will be received, because as soon as gateway number 2 see the superior VRP hello, it stops sending its own advertisement. Now it is only receiving the advertisement from the gateway number 1. The next step to check is to find out how actually the VRP failover works. First of all, we can do failover in a manual way, and to do a manual failover from gateway number 1 to gateway number 2, what we need to do, we need just to increase the VRP priority of gateway number 2, and this will make it a VRP master firewall. To do so, we need a command set mcvr VRID 100 priority is more than 150, let's say 155. And if you do show VRP, we see after a few seconds it switched to the master state. Show VRRP on the other hand shows that gateway number 1 is now in backup state. To failover back, we can again do the same command but decrease the priority, and after a few seconds we do show VRRP and see that gateway number 2 is now backup state and gateway number 1 is in master state. Let's try and do the same failover but not manually. We will do it with a plain with a VM interface, and we will disconnect adapter number 2, which is Ethernet 1. Show interface Ethernet 1. And we see that state is on, but link is down. Show VRRP. We see that that's the master state. And show VRRP on the other firewall, say that it's backup state, but backup state only for one interface instead of two interfaces because one of the interfaces is down. Let's try to re-enable the interface, make it connected again. Let's wait a few seconds, do show VRRP. Show VRRP shows now again the firewall is in master state. The firewall number 2 is in the backup state. To check a little bit more about why one or another failover happened, we can go back to the expert mode and we can do the following command. We can do cat var log route d messages, and in route d messages we can grep for VRID. Let's expand the window to see the full output in more details. And here we see what exactly happened with the VRRP. And here we have this status that we discarded packet because we were in master, and here we have the state change when we became a backup, when gateway number 1 became a master, and again when it went through the states from init to backup, and then to master. To align time with the VRRP state change and when the interfaces went down, we can do another command. It's cat var log messages and grep for interface card changes. And here we see when the interface went down, and here we see when the firewall went to the backup state, and here we have the interface is up, and at the same time we see the transition from the backup to master after exactly 3 seconds of the dead interval. And this concludes our video about a VRP cluster. We reviewed how to configure VRP cluster and how to create a VRP cluster object in SmartConsole. Also, we saw that the VRP may create for us a little bit of a problem when during the initial setup gateways may be backup, and from the other hand it may be master state. As we saw, VRP communication does not present in implied rules. We had to add a manual access rule for the VRP traffic to be allowed by policy.